talked to you about this yesterday. What is the domain on every single one of these?
All real numbers.
All real numbers. Okay. Y-intercept. Can you look at this? Much easier looking on this versus a graphing calculator. Can you clearly see where this thing crosses the y-axis? 5. Okay. The range. Let's kind of look. Where does this graph stop? Like when I'm graphing, it kind of flattens out at what number? 4. And then it's everything above. So it would be y is okay. The asymptote is like the line that we get close to but not touch. What line is that? 4. How do we write the equation of that line? Y equals 4. So you have to have the y equals. What do you notice? Where all am I seeing the 4? My range value, my asymptote value. We also had that plus 4 right there. Do you think they're all related?
No.
No? Okay, let's try another one. I want you to graph. Let's do 2. And then time, so I want you to do a parenthesis. Let's do 1/3, so 1/3. Do your parenthesis. To the x power. And let's put a -2 on the end. And I want you to answer the same question. So I want you to graph this. Tell me the y-intercept, range, asymptote. All right, so let's see if we have the same pattern. What's the domain?
All real numbers.
All real numbers. I didn't ask this on the last one. Is this growth or decay?
Decay.
Decay. That means as I go from left to right, is it rising or falling? So it's getting smaller, it's falling, so that's decay. Y-intercept. We can see here, where does this hit the y-axis? 0. Range. We can clearly see, you can zoom in. Where does this thing start? -2. So then we're everything above that, so my range is y is greater than -2. Okay, my asymptote, the line we're getting close to but not touching, is y equals -2. So let's see, did it happen again? We have the -2 here, here, and right there. Okay, so that adding or subtracting on the end, it's changing your range and your asymptote. Where your range starts, that's where the horizontal asymptote occurs. All right, let's look at our notes. Then we have a few of these left that we're going to do. But what I want you to do is use Desmos to try to graph this. Okay, we can still plug in points, certainly, and get some exact ones. But let's use Desmos and see if we can get an idea of what the graph looks like. So we have 1/3 to the x plus 4. Okay. We have to graph this because we have that slide with a graph. Can we get some points? We could do it a couple different ways, couldn't we? We could get it from this, or like we did yesterday, making that table of values. It's not too hard to get just a few points, which is really all we need. You could certainly plug in like 0, 1, you need a negative. points that way. We can look at this graph and tell, what is this point? 0, 5 is a point on my graph. And if you just click on that graph, it tells you points. So you can get them either way. So if I need another one, okay, when it's 1, if I could get it exactly, 4.33. Is that the same thing I would get if I plugged a 1 into this equation? Went to my calculator, 1/3 to the first with plus 4? Yeah, just two different ways of getting it. Alright, so that's just to give me an idea of what this graph looks like. When I'm looking at it, can you tell me, is this growth or decay? Decay. How do we know that? It's falling. Alright, so let's get enough points. We probably need one more on our graph, don't we? So maybe -1, 7. And where does this graph kind of flatten out? Oops, that fell too far. So I did less exact points today, but I just kind of used that other one. We said this was decay. Domain, no matter what, is all real numbers. The range, where does this graph start? At 4, and it's above 4, so the range would be the y-intercept. Where do we hit the y-axis? At 5. Okay, the asymptote is y equals 4. You know, the 4 is the range value, the asymptote value, that's the number we were adding on the end. I want you